Hello, good morning, students. We are meeting again with this new topic alcohols, phenols, and ethers. Now, about alcohols. These alcohols, phenols, and ethers are basic compounds for the formation of detergents, antiseptics, and fragrances, respectively. So, these are the basic compounds for formation of detergents, antiseptics, and fragrances, respectively. Means these are present in detergents, antiseptics, and different types of fragrances. Alcohol phenols are formed when hydrogen atom in aliphatic hydrocarbons or aromatic hydrocarbons, respectively, is replaced by OH group. So, hydrogen atom in aliphatic hydrocarbons, RH alkanes, or aromatic hydrocarbons, ARH, like as benzene or benzene derivatives. The hydrogen atom is replaced by OH group. Then the obtained compounds are alcohols and phenols. Means from alkanes, when one hydrogen is replaced by OH, then we get ROH. These are alcohols. And in benzenes or aromatic rings, C6H6, one of the hydrogen is replaced by OH group, then they will become C6H5OH. These are called as phenols. Okay, means hydrogens from alkane or aromatic hydrocarbons, aliphatic or aromatic hydrocarbons, when replaced by OH group, the obtained compounds are called as alcohols or phenols. Okay, these classes of compounds find wide applications in industry as well as day-to-day life. For example, spirit. For example, spirit. So this spirit is used for polishing the wooden furniture. Polishing the wooden furniture, which is having ethanol as a main compound, and this ethanol contains OH group. Spirit is wood polish. The sugar we eat, it has also hydroxyl group present. The cotton fabric, the cotton which is used for fabric, has also OH group in its formula. The paper we use for writing, these all are made up from the compounds containing OH group. So these are the examples which we use in our daily life. Spirit, sugar, cotton, paper. So they all contains OH group as a main functional group. Means these alcohol, phenols, and ether plays very important role in our day-to-day life. Okay, now let us see. An alcohol contains one or more hydroxyl OH groups directly attached to carbon atom or atoms of an aliphatic system. while phenol contains OH groups directly attached to carbon atom or atoms of an aromatic system. So get clear here. What is alcohol? So alcohol is nothing but it contains one or more hydroxyl group by replacing one or more hydrogen from different carbon atoms of an aliphatic system. Aliphatic system means alkane, alkenes, alkynes. Okay, here one example is given CH3OH. And what is phenol? Phenol contains OH group or groups, one or more hydroxyl groups directly attached to carbon atom or atoms of an aromatic system. So this is example C6H5OH. Okay, means alcohols are derived from aliphatic hydrocarbons and phenols derived from aromatic hydrocarbons. Okay, the substitution of hydrogen atom in hydrocarbon by an alkoxy or aryloxy group. This is alkoxy and this is aryloxy group. Oxygen attached to aromatic ring, oxygen attached to alkyl group. So this is alkoxy and this is aryloxy. Yields another class of compound which is known as ethers. For example, CH3O CH3 dimethyl ether. I can get clear here. Substitution of hydrogen atom in hydrocarbon. Suppose it is hydrocarbon is RH, and from this hydrocarbon, one hydrogen atom is replaced, it is substituted or replaced by alkoxy or aryloxy group. That is, hydrogen is replaced by OR or OAR group. It gives new compound which is called as ether. For example, now here initially this is CH4. It is CH4, and in this CH4 hydrogen is replaced by OCH3 group. Hydrogen is replaced by OCH3 group. Then it is called as ether. This is ether. See, now classification. So we have seen the concept or the definitions of alcohols, phenols, and ethers. Now classification of alcohol, phenols, and ethers. Alcohols and phenols may be classified as mono, di, tri, or polyhydric compounds depending on whether they contains one, two, three, or many hydroxyl groups respectively in their structure as given below. So alcohols and phenols are classified as monohydric alcohol, dihydric alcohol, trihydric alcohol, or polyhydric alcohols, or phenols also monohydric phenols, dihydric phenols, trihydric, or polyhydric phenols. So it depends on whether they contains one, two, three, or many hydroxyl groups respectively in their structures. So, for example, C2H5OH. C2H5OH. It has only one OH group. So it has only one OH group. Okay, this is another example. So this benzene ring, and this contains only one OH group. So they are known as monohydric alcohols or monohydric phenols. This is monohydric alcohol and this is monohydric phenol. Now see here, alcohol means this is aliphatic hydrocarbon C2H6 ethane, and from this ethane one hydrogen is replaced by one OH group. So it is alcohol, and it was initially benzene C6H6, and from this carbon one hydrogen is replaced by one OH group. So this is phenol. This is phenol. Okay. This alcohol and this phenol both contains one OH group by replacing one hydrogen of corresponding aliphatic hydrocarbon and aromatic hydrocarbon. They are called as monohydric compounds. Now this is dihydric. See here in this example, CH2OH and CH2OH, two hydroxyl groups. Here, two hydroxyl group. See this example. In this example, this benzene contains one hydroxyl group and this is second hydroxyl group. So as two hydrogen atoms from aliphatic hydrocarbon replaced by two OH, it is dihydric alcohol. This is dihydric alcohol. And in this aromatic compound, hydrogen from this carbon and hydrogen from this carbon, both hydrogens are replaced by two hydroxyl groups. So it is dihydric compound. So these are dihydric compounds. Trihydric. Now you may get idea about this trihydric. So these are trihydric. This is trihydric alcohol. So one OH group, this is and this is third OH group. So by replacing one hydrogen from this carbon, second hydrogen from this carbon, and third hydrogen from this carbon. So by replacing three hydrogens by three hydroxyl group, this alcohol is trihydric alcohol. And here in this example, the basic compound is benzene, aromatic ring. And from this carbon, from this carbon, and from this carbon, three hydrogens are replaced by three hydroxyl groups. So this is trihydric compound. This is trihydric phenol, trihydric alcohol, and this is trihydric phenol. Okay. Now, see, alcohols and phenols are classified as monohydric, dihydric, trihydric, or compounds on the number of hydroxyl group. If one hydroxyl group, then it is monohydric. If two hydroxyl groups, then dihydric. Three, then it is trihydric. And more than more than three hydroxyl groups, if present, then it is polyhydric compound. Now, monohydric alcohols may be further classified according to hybridization of carbon atoms to which hydroxyl group is attached. Classification. So we are going to see about this monohydric alcohols. So they are further classified according to the hybridization of carbon to which OH group is attached. Now first, compound containing CsP3OH bond. Okay, the COH bond, carbon attached to OH. The nature of this carbon or hybridization of carbon is sp3, means the hydroxyl group is bonded to sp3 hybridized carbon. Okay, in this class, in this class of alcohols, the OH group is attached to an sp3 hybridized carbon of alkyl group. This type of compounds or alcohols are further classified as primary, secondary, and tertiary alcohols. In these three types of alcohols, OH group is attached to primary, secondary, and tertiary carbon atoms respectively, as given below. Okay, so we know what is primary carbon. So OH is attached to this carbon, which is directly bonded to another carbon. It is primary alcohol. Now see this OH. OH is attached to this carbon, which is directly bonded to another two carbons. Here these two free bonds are shown. So they are bonded with another carbon, another alkyl groups or maybe aromatic groups. But this carbon is directly bonded to another carbon and to this another carbon. Okay. So such type of alcohol is secondary alcohol. Now you may clear. So OH is attached to this carbon. This carbon is sp3 hybridized carbon. Okay, and which is bonded to first carbon, second carbon, and third carbon. So this is tertiary. Now here before this we must have to recall our knowledge. What is sp3 hybridized carbon? If carbon is bonded to four different bonds, bonded with four different bonds, then it is because of sp3 hybridization. With formation of sp3 hybridization or formation of methane molecule that already we have studied in 11th standard in nature of chemical bonds. Okay, because that carbon has four bonds, CH4. There are four CH bonds. So carbon carbon single bond, it has sp3 hybridization. So in these all examples, primary alcohol, secondary alcohol, tertiary alcohols, so these carbons are sp3 hybridized carbon. This is sp3 hybridized carbon. This is also sp3 hybridized carbon, and this is also sp3 hybridized carbon. But further, it is bonded with another one carbon, so it is primary. This sp3 carbon bonded to another two carbons, so it is secondary, and this is tertiary. Okay, allylic alcohols. Next type is allylic alcohols. What is this allylic alcohols? In these alcohols, the OH group is attached to sp3 hybridized carbon next to carbon carbon double bond, that is to an allylic carbon. So here let us see, OH is attached, OH is bonded to this carbon which is bonded to the carbon which is attached to double bond. So this carbon is bonded to allylic carbon. Allylic carbon means that carbon having carbon-carbon double bond. So this carbon-carbon double bond. So such type of alcohols are called as allylic alcohols. These are called as allylic alcohols. Now see in this example, OH is bonded to this, OH is bonded to this carbon, and which is bonded to carbon-carbon double bonded carbon. Okay, so this is allylic carbon. Here in this example, OH is bonded to the carbon which is bonded to allylic carbon. Next to it, double bond is present, double bonded carbon is present. And primary, this is primary, this is secondary, and this is tertiary. So why primary, secondary? Just recall. So OH is attached to this carbon which is directly attached to only one carbon. So this is primary carbon. Dot. This is secondary carbon. This carbon is secondary carbon. Two dot. Okay, because it is bonded with one carbon and this is second carbon. This is tertiary carbon. Tertiary carbon because this is bonded to first carbon, this is second carbon, this is third carbon. Okay, so this is tertiary one. So this is allylic alcohols. So what is in this allylic alcohols then? OH is attached to the carbon next to double bonded carbon. Carbon-carbon double bond. Okay. Benzylic alcohols. Next type, next class is benzylic alcohols. In these alcohols, the OH group is attached to sp3 hybridized carbon next to aromatic ring. Next to aromatic ring. See what is difference in benzylic and allylic alcohols. What was the next? Allylic alcohols. What was the previous? Allylic alcohols, and this is benzylic alcohols. Here OH group is attached to this carbon which is directly bonded to benzene ring. See, OH is attached to this carbon which is directly bonded to this benzene ring. Here also OH attached to this carbon which is directly bonded to benzene ring. Okay. See, OH bonded to this carbon which is directly bonded to carbon of aromatic ring. Okay, and here this is primary because this carbon is bonded to only one carbon. So this is primary benzylic alcohol. Why this is secondary? OH is attached to this carbon which is directly bonded to carbon of aromatic ring. This is carbon of aromatic ring. And why it is secondary? Because OH is attached to this carbon which is directly bonded to another carbon. This is secondary because this is first carbon and this is second carbon. This is OH is attached to this carbon which is directly attached to carbon of aromatic ring. And why it is tertiary? So this is this carbon on which OH group is present, which is bonded to first carbon. This is second carbon. This is third carbon. So this compound is tertiary. Okay. Allylic and benzylic alcohols may be primary, secondary, and tertiary. So that we have seen. Compounds containing COH bond, but this carbon is sp2 hybridized. This is sp2 hybridized carbon. Means OH is attached to sp2 hybridized carbon. Okay. These alcohols contains OH group bonded to, let me take a laser, OH group bonded to a carbon-carbon double bond, that is to vinylic carbon or to an aryl carbon. These alcohols are also known as vinylic alcohols. These are also known as vinylic alcohols. Now again, recall about sp2 hybridized carbon. So in nature of chemical bonds, which topic we have studied in 11th standard, and in this formation of alkene, formation of alkene we have studied, alkene has carbon-carbon double bond. So the carbon which has double bond is always sp2 hybridized carbon. It is sp2 hybridized carbon. Now here, check in this example, in these both examples. So this carbon is sp2 hybridized carbon. Means OH is attached to sp2 hybridized carbon directly. In this example, OH is attached to sp2 hybridized carbon because this carbon has double bond. Carbon has double bond. So this carbon is sp2 hybridized carbon. This is also sp2 hybridized carbon. This is also sp2 hybridized carbon, but we need only here because OH is attached to sp2 hybridized carbon. In this example, this OH is bonded to sp3 hybridized carbon. This carbon is sp2 hybridized carbon. So all carbons in benzene ring, these are sp2 hybridized carbons. Is it right? Because each carbon contains carbon-carbon double bond. But what about this carbon? This carbon is not sp3 hybridized carbon. It is not sp2 hybridized carbon. It is sp3 hybridized carbon. Okay. So these vinylic alcohols are the alcohols in which OH group is bonded to sp2 hybridized carbon or direct to that carbon which is doubly bonded or which has double bond. Okay. Now next about ethers. About this ethers. Ethers are classified as simple or symmetrical. If alkyl or aryl groups attached to the oxygen atom are same. So recall the structure of ethers. Ethers has or ethers are the compounds which has oxygen bonded to two alkyl groups or alkyl or aryl groups. Okay. If both alkyl groups to which oxygen is bonded are same, then it is called as simple or symmetrical ether. If both are different, here C2H5 bonded to oxygen and another alkyl group is methyl. So both are different. This is ethyl group and this is methyl group. So it is unsymmetrical or mixed ether. There is no symmetry. One is ethyl group and another is methyl group. So this ether is mixed type of ether or it is unsymmetrical ether. And what is here? This is ethyl group and this is also ethyl group. Both are same. So it is simple or symmetrical. There is symmetry. Across this oxygen, there is symmetry. One is ethyl group, another is also ethyl group. Same groups are here. So this is simple ether or symmetrical ether. See this example to this oxygen. One is ethyl group bonded and another phenyl group is bonded. So both groups are not symmetrical, not same. So it is called as, this example of ether is called as mixed ether or unsymmetrical ether. Now nomenclature. Nomenclature for alcohols. First, so there are some rules. We have to follow these rules for nomenclature of alcohols. First rule: the longest continuous chain (LCC), longest continuous carbon chain of carbon atoms containing OH group is taken as parent compound, an alkane with the same number of carbon atoms. The chain is numbered from the end nearest to OH group. So select the longest continuous carbon chain as parent alkane and we have to number this chain from that end which is closer to hydroxyl group, which is near to OH group. Okay, so this is the first and basic rule. Second rule: the number that indicates the position of OH group is prefixed. The number that indicates the position of OH group is prefixed to the name of parent hydrocarbon, and the E ending of parent alkane is replaced by suffix OL. Prefix and suffix. Let us see by taking one example, but before seeing that example, we have to read it. In cyclic alcohols, the carbon atom bearing the OH group is designated as C1. If the alcohol is cyclic alcohol, then OH group present on the carbon, that is considered as C1 carbon, or it is numbered as first number. But the number 1 is not used in the name for cyclic compounds, cyclic alcohols. Substituents are named and numbered as in alkanes. If that cyclic compound contain any other different branch, side chain or substituents, they should be named and numbered similar as similar rule as in alkanes. Okay, now let us see here CH3OH. Now OH attached to methyl group. Methyl group has only one carbon. It has only one carbon. So its IUPAC name is methanol. Methanol. Suffix is OL. Suffix is OL, and here E of alkane. It is derived from methane. So E of alkane is substituted by word OL. See second example CH3, CH2, CH2OH. So there are three carbons. Three carbons means this compound, this alcohol is derived from propane. It is derived from propane, which has three carbons. Now number the chain. This is first carbon to which OH is attached, or OH is near to this end. So this is first carbon, this is second carbon, and this is third carbon. Now propan 1 all, the position of OH group is at first carbon. So that position is prefixed. Prefix means right previous. Okay, this is propan 1 all. Propan 1 all. In this example, one, two, three carbons, but OH is attached to this carbon. Second carbon, this is first, second, or third, and third, or number by this end, 1, 2, and 3. So on second carbon, there is position of OH. So propan 2 all. So what we have done here, replace E by OL. So this is propanol. This is propanol. But what is the position of OH group? Position of OH group, OH is present at the second carbon. So it should be prefixed. It is indicated before OL. So propan 2 all. Propan 2 all. Here, see from this name, butan 1 all. What this indicates? OL means it has hydroxyl group. 1 means hydroxyl group present at the first carbon, and butane means this compound, this alcohol has total 4 carbons. Okay, see 1, 2, 3, and 4. So 4 carbons, butane, replace E by word OL, butanol, and before the word OL indicate the position, prefix the position of OH group, that is at first carbon, because OH is present at first carbon. In this example, butan 2 all. So OL hydroxyl group, it is present at second carbon of butane. Second carbon of the butane. See, 1, 2, 3, 4 carbons. 4 carbons, it is butane. In this second carbon, the hydrogen is replaced by one hydroxyl group, OH group. So this is first carbon because OH is closer to this end, first carbon, second carbon, third, and this is fourth. So what is the name? Butan 2 all. Okay, it is butan 2 all. Again, see another these examples also, 2 methyl propan 1 all. So in this example, so we are going here from name to structure. If you get idea about these nomenclature rules, so from this name we can write the structure also. So 2 methyl propan 1 all. 2 methyl propan 1 all. So OL means hydroxyl group 1, Position of hydroxyl group at first carbon of propane. Parent alkane is propane. And at second position, methyl group is present. Let us see. So here, this is the parent compound having maximum carbons in longest continuous carbon chain. First, second, third. So this is first carbon, this is second carbon, and this is third. This is third carbon. And at second carbon, this branch or side chain is present. This side chain is of methyl group. Side chain is of methyl group. So the name is 2-methyl propan 1-ol. In this example, see, in this example, the longest continuous carbon chain. So I am selecting this chain as longest continuous carbon chain containing 3 carbons, 1, 2, and 3 carbon. Okay. So in this chain, OH is present at this carbon. So this is first, this is second, this is third carbon. OH is present at second carbon, and at this second carbon, this branch methyl group is also present. So 2-methyl propan 2-ol. 2-methyl propan 2-ol. Okay. Now, before the nomenclature, we must have to see the third rule. Let us see what is this third rule. If more than one hydroxyl groups appears in the same molecule, that is polyhydric alcohols, suffixes such as diol, triols are used. If 2 hydroxyl groups are present, and then say diol. If 3 hydroxyl groups, then triol are used. In these cases, E, the ending of parent alkane, is retained. So this E should be kept as it is. It is retained. Now let us go and see this example. So 1, 2, 3 means parent alkane is propane. In this propane, from all these carbons, 1 hydrogen is replaced by 1 OH group, means total 3 hydrogens are replaced by 3 hydroxyl groups. So the common name is glycerol, and the IUPAC name is propan. 1, 2, 3 triol. 3 hydroxyl groups, so triol. And where these 3 hydroxyl groups are present? At first carbon, second carbon, and third carbon. Okay. Cyclic alcohols are named using the prefix cyclo and considering the OH group attached to C1. Now this is cyclohexane. This is cyclohexane, and OH attached to this carbon, it is considered as first numbered carbon, that is C1. So this is cyclohexanol. E, cyclohexane, E is replaced by OL. E is replaced by OL. But in this, the position of OH is not mentioned, is not indicated. See here, in cyclic alcohols, the carbon atom bearing OH group is designated C1, but the position of hydroxyl group, that is 1, it is not used in the name. Okay, so here cyclohexanol. Now see this example. This is cyclopentane. This is cyclopentane. OH is present. This carbon should be considered as first, and next carbon is second carbon. So 2-methyl cyclopentanol. 2-methyl cyclopentanol. Okay. Now for phenols, the simplest hydroxy derivatives of benzene is phenol. Hydroxy derivative is Hydroxy derivative of benzene is phenol. It is its common name and also accepted by IUPAC system. So this phenol is common name, and this same name is accepted by the IUPAC system. As structure of phenol involves a benzene ring in its substituted compounds, the terms ortho. So recall the knowledge, recall your uh, knowledge for ortho position, meta position, and para position, which already we have studied in 11th standard. Aromatic compounds, in the topic aromatic compounds. What is ortho position? 1-2 position, it is ortho position. So 1-2 substituted, this is ortho position. Meta means 1-3 substituted, and para means 1-4 substituted. These are often used in common names. Ortho, meta, para, these words should be used in common nomenclature of phenols. But by number, we can use, we can say in the IUPAC nomenclature system. See, this is phenol. Phenol. Common name is phenol, and IUPAC name is also phenol. Here, orthocresol. Orthocresol. So this is ortho position. This is ortho position. But according to IUPAC system, so this is first carbon and this is second carbon. At second carbon there is methyl group. So 2-methyl phenol. The parent compound is phenol. Here metacresol. It is metacresol. So this position is meta position. This is meta position. Third position, or this is also meta position. Okay. So at third position there is methyl group, 3-methyl phenol. This is 4-methyl phenol. So this fourth position is para position. This is para position. Now in this example, dihydroxy derivatives of benzene are known as 1,2 or 1,3 and 1,4 benzene diol. See, in this example, this is first, this is second. At first carbon and second carbon, both contains diol, dihydric or dihydroxyl groups. So the common name is catechol, and IUPAC name is benzene 1,2 diol. Benzene 1,2 diol. Now here in this example, this is first position, second, and this is third. It is resarcinol, or the IUPAC name is first and third benzene 1,3 diol. This is hydroquinone or quinol, and the positions, this is first, second carbon, third carbon, and this is fourth carbon, benzene 1,4 diol. Okay, so this way the phenols can be named according to IUPAC system. Now about ethers. about ethers, nomenclature, IUPAC nomenclature of ethers. Now here we will see common as well as IUPAC nomenclature system. Common names of ethers are derived from the names of alkyl or aryl groups written as separate words in alphabetic order and adding the word followed by the word ether at the end. For example, this is the compound CH3O C2H5, CH3O C2H5. Now here to this oxygen, one methyl group and second ethyl group is bonded. Okay, so alphabetically E of ethyl comes first, then M of methyl. So indicate by taking separate names of the alkyl groups. Ethyl, methyl, ether. So what is the name? Ethyl, methyl, ether. The name is ethyl, methyl, ether. If both are ethyl groups, then diethyl ether because ethyl group present two times diethyl ether. If both are methyl groups, then dimethyl ether. Okay. According to IUPAC system, ethers are named as alkoxyalkanes. They are called as alkoxyalkanes. So why alkoxyalkanes? Because in definition we have seen that RH, this is alkane, and from this alkane hydrogen is replaced by alkoxy group, OR group. Okay, so they are called as alkoxyalkanes. They are called as alkoxyalkanes. The larger alkyl group is considered to be parent alkane. The larger alkyl group is considered as parent alkane. The name of smaller alkane is prefixed by the name of alkoxy group and with its locant, with its position. See, for example, so there is no problem to write the IUPAC name of simple ethers, symmetrical ethers, which has symmetrical alkyl groups. For example, see here CH3, OCH3, both groups are methyl. So the common name is dimethyl ether, methyl group two times, so dimethyl ethers. And the name is methoxy. This is methoxy and derived from methane. So methoxymethane. Here C2H5O CH3, ethyl, methyl, ether. See here, let me change. Both are here according to name. It is diethyl ether. Let me correct here. This image is taken from the book. Let me correct it. So C2H5, C2H5O, C2H5. So diethyl ether or it is ethoxy ethane. So this is ethoxy part and derived from this ethane. In this ethane, C2H6, one hydrogen is replaced by this OC2H5 group. So this is ethoxy group. This example C6H5OCH3. This example is mixed ether. Larger group is this group, benzene group. Benzene is considered as larger aromatic compound. So in common name it is methyl phenyl ether. Methyl, this is methyl group and this is phenyl group. So methyl phenyl ether. But According to IUPAC system, the smaller group is considered as alkoxy group. This is methoxy group, methoxybenzene, methoxybenzene. Now here, this is the larger group. This is larger group, and in this larger group, three carbons. So it is derived from propane. This compound is derived from propane. This is first carbon, this is second carbon, and this is third carbon. Okay, to this second carbon, this methoxy group is bonded. Okay, so see this IUPAC name first. 2-methoxy parent alkane is propane. Larger group is considered as parent alkane, and smaller group as alkoxy group. And what is IUPAC name? Sorry, common name. This is methyl group. Across this oxygen, one is methyl group and one is propyl group, but this is isopropyl group. This is isopropyl group. Okay. Now let us solve these examples. Give write IUPAC names. Give IUPAC names of the following compounds. Now here, look carefully. What is the first rule? Select the longest continuous carbon chain. So 1, 2, 3, 4, 5. So this is derived from pentane. OH is present at this carbon. So numbering should be done by this end. First, second, third, and fourth. At fourth carbon there is chlorine. Second, third, these both carbons containing methyl group. So what is the name? 4-chloro. Alphabetic order C. Fourth chloro, 2, 3 dimethyl. This is methyl and this is also methyl. Pentan 1 all. Pentan 1 all. Okay. See this second example. This second example. This second example has oxygen bonded to different alkyl groups. This is ethyl group and this is isopropyl group. Just recall, the larger alkyl group is considered as parent alkane and smaller one as alkoxy group. See what is the name? 2-ethoxy. 2-ethoxy propane, because this is second carbon. At second carbon, this ethoxy group is bonded. So 2-ethoxy propane. Here, in this example, this carbon is considered as first carbon. Second, third, fourth, fifth, and this is sixth. So 2,6. At 2,6 position, these two methyl groups. Okay, so 2,6 dimethyl phenol. 2,6 dimethyl phenol. Now see this example: 1-ethoxy, 2-nitrocyclohexane. Now the basic compound is cyclohexane. This is cyclohexane. This carbon is considered as first carbon. At this first carbon, ethoxy group is present. And next, the closure number 2. It may be by clockwise or anti-clockwise direction. So here anti-clockwise direction, the closure number where the side chain is present of nitro group, this is second. So 1-ethoxy, 2-nitrocyclohexane. Okay. So up to this nomenclature, we have studied about this introductory part of alcohols, phenols, and ethers, about their definitions and their nomenclature system. Okay, let us stop here. We will continue the topic, next topic, in our next lecture. Okay, thank you.